Awesome. I think we'll go ahead and get started now. So once again, everyone on the call, thank you so much for taking some time out of your afternoon to spend with us. Once again, I'm Eddie Mitchell, the solution architect here at Polarity, and I'm joined by Vitaly Kremez, who's the CEO and founder of Advanced Intel. So this is a short power-up session on YARA rule writing. Before we get through that, I'm just going to kind of, for those folks on the call that aren't familiar with Polarity, I'm just going to kind of give like a brief introduction to what Polarity is and the problem set that we tackle. And then I'm going to turn it over to Vitaly so he can go through his content. So Polarity, for those of you that aren't familiar, is an analyst-driven tool that is squarely focused around solving the fundamental problem of search. So what we find with the customers that we work with, whether we're talking about commercial enterprise customers or some of our government clients in the public sector, is that these analysts on these teams have a lot of different sources of information that they're working within on a daily basis. And this could be information sources scattered internally throughout the enterprise, or also external sources, commercial tools, data sources, tools, and also open source data platforms, and so on and so forth. So the consequence of this, all these different data sources, is that these teams are spending a significant amount of time out of their daily routine performing search, manually gathering bits of information from these different platforms to facilitate their research and ultimate decision-making process. So at Polarity, and this is just an example like from an incident response platform where there's a lot of different data points on the analyst screen, and then we're having to have the analysts rapidly contextualize all these data elements on their screen. So Polarity is squarely aimed at bringing contextual information to the analyst based on a recognition of these data points on their screen automatically, alleviating the need from having to manually gather this information. I'll give an example of that at the end of the call when we sort of discuss the capability specifically around our YARA Finder integration and how do we speed up identification of YARA rules related to perhaps different malware samples that are currently being analyzed. So with that, I'm going to stop with the introduction to Polarity, and I'm going to go ahead and turn it over to Vitaly for the YARA rule finder portion of the briefing.
Thank you so much, Eddie. It's a pleasure for us, for Advanced Intelligence, to be part of this workshop. And our goal here is to talk about some of the unique capabilities that YARA offers us in general as threat researchers or intelligence analysts focused on finding the most important or crucial aspects related to the malware analysis. And then YARA is just such a wide framework and implementation has across so many different sectors. So we'll talk more about the YARA and its hunting for those key areas of interest, and we'll talk about the specific primer of them as well. Hopefully you can see my screen now. So the YARA essentially for us, it's a Swiss Army knife needed for malware researchers and threat intelligence analysts. We believe in this philosophy that the malware developers are essentially software developers. They create and reuse code across their malware samples. So in many cases, when we think about the malware or thinking about any malicious software, at its core, it's a software, meaning that we can catch specific adversaries and operators when they make certain repetitive tasks. Oftentimes, as you all know, when you're a coder, you don't code the same routine twice. You copy paste across different code bases you have. That's what we all do as humans. So we try to exploit that feature to catch and be efficient. That's what we do at Advanced Intelligence, and have to share our insights. So in this case, you can see we'll talk about briefly the use case of doppelpayment ransomware and PAMX intrusion, which has a very specific signature to it. But before we dive deeper into that, actually, I need to a little bit update my slide as well. But one of the latest version of YARA, I believe it's 3.12, but I'll double check that quickly. But what's the primary use and initially development of YARA was to classify and identify malware samples. It's a rather simple Ruby-based language syntax, and it's simply in a few key terms to describe it. It's essentially a grep. It's a grep which searches for unique information within the non-standard files or any elements of those. So it's a signature-based tool. In many cases, if we think about the YARA, it's a static signature tool that's used to identify patterns within the files that speak to their commonalities. It's essentially using YARA as the way we use it. We make it as an efficient static antivirus engine, essentially. So that's what YARA is for us. It detects files and maliciousness across them based on the unique characteristics that are non-traditional. So the typical YARA syntax is as follows, as you can see on the screen. Wherever we can import different modules, we can type the rules and make them rule types. There's super rules that exist and tagging. And you can see there's a specific categories and classification of these rules where we have a category of meta. Meta oftentimes specifies specific metadata around the rules itself. So it's actually sort of like a comment section within the code that you can comment and make it provide contextual analysis to make it work, as well as the string section. String section is one of the most important ones, obviously, because the sections identify specific patterns we document and observe as part of YARA. One of the key features I want to also emphasize, YARA is good for string matches and also opcodes or other hexadecimal matches as well. Oftentimes we hunt for not only for direct string matches, but also look for the code similarities across malware samples, which can be represented in opcode or hexadecimal format as well. And you can also see that there's a conditions. Condition, it's basically the formula and the algorithm behind the matching logic, how to basically those strings tie together to make it a whole. What's the recipe of this maliciousness? So to think about the cookie that we prepare with the secret sauce, what makes this malware click. And we'll talk briefly related to that with one specific Drydex example. But this is simply, in the simple terms, this is a Ruby-based language which follows the same annotations we observe with Ruby, similar connotations, but it also can be applied across the samples. As again mentioned, the additional modifiers that exist, including super rules and private rules and global that exists, and the specific logic that follows, where we mean by global, it's we match before any subsequent rules. We can specify private rules in order to build other rules or none, which is basically matches unless the global is used. There's specific syntax that already pre-built with YARA that can be super efficient. And YARA is continuously being developed and innovated and created and expanded, including to in the base 64, for example, modifiers as well. And you can see the tags are also as files can be strings, can be also regular expressions. There's a certain computational and mathematical trade-off when you use those, but that exists, of course, for any analysts and researchers such as myself. When we find the most interesting samples nobody else could find, we use a combinations of different tools and scenarios. Also, the conditions can be, as you can see, different ones, where we think about the Boolean expressions, or think about the built-in external or module variables. YARA is such a huge engine, and it has so many wide applications, and it's a complex, sort of like a grep, but it's more than just that. You can hunt for malware, but you can also hunt for different attributes. For example, compromised credentials whenever they surface across the sort of different engines. And that's something also exists. What I loved doing, part of my sort of like secret recipe, is looking for the string and code reuse hunting. So the most efficient YARA signatures I've ever seen in my entire life is that those that are focused on two elements. Oftentimes, it's not enough automatically to generate YARA signatures, string signatures. Oftentimes, it requires us to identify code patterns within the malware samples. So usually, we follow the 7-step process, which requires us to analyze the malware, identify string and code uniqueness across the samples, prototype the YARA rule based on the findings, come up with what is unique about the sample set. Then test. Oftentimes you test across diverse malware family to see if it matches across all the other families. Oftentimes you'll see that some malware operators use the same packer or the same cryptor, for example, to basically protect its code. So oftentimes you actually look for packers and cryptors across malware families, but so there's going to be a lot of interesting discoveries can be done across the testing process. Number 5 is to deploy for hunting. There's many ways where you can deploy it. Certain rules and engines, for example, URL house allows you to get live YARA notification hits for the samples they observe. So that exists, of course. Please feel free to use in URL house. It's one of my favorite resources across hunting for YARA, and then review and monitor for possible false positives and or false negatives that outside of the testing phase and initial malware analysis. The reason why we need to be looking for possible false positives because oftentimes the malware developers will introduce new features, or they would hide actually to protect against the YARA signature matching. So it's always a cat and mouse game where we as researchers, as we are security professionals, we try to be ahead of the adversarial perspective, so to speak, and we try to hunt them down and look for commonalities across their code. It's really YARA is in many ways, you're looking, hunting for the code across different malware samples and developers basically across them. So it's just, and repeat the 7 steps. So basically it's the cyclical nature of you reviewing malware analysis and finding unique string and code reuse patterns. Just for example, look about Drydex. Drydex has a specific malware family kinship that unites both Drydex, Doppelpaymer, Hades, and also Wasted Locker. So there's a lineage of groups that have similar, share the same code. Oftentimes it's labeled as API hashing, some other subroutines, but you can clearly see it's been coded by the same person or same group of developers. Oftentimes we've been asked, how do you identify that this is the same developer who wrote it? And the key here is YARA and code reuse signatures across of it. So sort of like a unique insight. This is an example of the specific YARA signatures. This is an example of a code reuse signature, which is, I think, in my humble view, it's one of the most important features. It's, for example, you can see this is an example of how to detect a family of malware. So it's YARA has such a huge application. And just to show you, this is a code where in opcoded hexadecimals, we represent the possible wild bytes across the malware family samples that can vary. Obviously, malware is oftentimes written in C style code, but also allows to decompile in C and apply the variations across the different compilers that exist in C code. So we account for different things that you can see in the question mark, which is with wild, sort of like with wildcards or with possible different variables adjusting for the size and for decompilers. So this is sort of like a very quick primer of what we expect YARA to be. It's expected to be a very rich static engine. We expect us to not only catch the malware families and samples, but also malware families. And it's not just simply a code string matching tool. It's also a code patterns, or rather code reuse. So it's a very powerful tool. The tool and its usage really depends on kind of like malware and analyst capabilities. You can always test the malware samples, or you can search or use the YARA command line tool to see specific malware hits and collections, as you can see through the dumps of malware, and also look for uniting and looking for unique attributes that connect back the Drydex loader, for example, and the Doppelpaymer payload. So there's lots of variations you can do, including the file size markers within those rules, including the rich metadata that allows you to reference both the hash files and also the provide guides for any subsequent researchers who are hunting for those YARA signatures. So very rich protocol exists, and highly recommend for you to get intimately familiar with YARA, because that's really one of them still is to the day, one of the most powerful tools. And if used in the right hands with the right approach, it can lead to revelations and discoveries we had earlier. For example, the Doppelpaymer Drydex connection, or any other malware tools and families you can never find before connections, you'll be able to find with YARA. So thank you. On this note, I would like to pass the controls back to Eddie, and thank you for joining the call.
Thank you so much, Vitaly. That was amazing. Really awesome stuff. So just pivoting back here to Polarity for a moment. So we have a very interesting capability that complements a lot of the capabilities of YARA that Vitaly just mentioned. So what we've done is we've created one of our close to 200 open source MIT licensed integrations that are available in our GitHub repository. And for those of you that are on the call that are perhaps Polarity Enterprise customers, as you know, you can take advantage of as many of our open source integrations as you want. And then for those of you that are Polarity Community Edition users, we would also invite you to leverage the same YARA Finder integration that I'm about to describe. So in the process of, conducting malware analysis, analyzing samples, as Vitaly was just describing to us, undoubtedly you're going to come across many unique strings within the malware, and you perhaps want to have the capability to rapidly search those various unique strings to see if existing YARA signatures have already been constructed and are available for you to download and use. So in this a really quick example, where I'm on a technical blog related to sunspot malware, I can come to one of these sections where they've analyzed some of these functions within the malware, and there's a unique string here that I want to either highlight with Polarity. And then in this case, I'm just going to highlight this unique string, and then I'm just hitting my keyboard shortcut within Polarity to execute our on-demand search. And you can see the Polarity overlay window automatically appears, and it's hitting and telling me via the YARA Finder integration that we've identified an existing result on github.com for somebody that's published a YARA signature previously that includes this unique string within the YARA signature. So I would be able to click on this link here and rapidly pivot to the YARA signature here in this case that includes that particular string that I've observed in this technical report. And this obviously, as you know, if folks are already used to leveraging the Polarity tool, this type of capability exists within any application window where I have the ability to select text and then hit the Polarity on-demand keyboard shortcut to initiate the enrichment request. And then you can also see within the YARA Finder integration, we can turn on and off at will different publicly available resources to search for YARA signatures. So these are just sort of like the built-in ones that we've included during the initial development process of the integration. But obviously we have the ability to rapidly expand this list with other sources where YARA signatures are commonly published. So I hope that helps and just gives a little bit of more insight in terms of how Polarity can rapidly increase the efficiency of your research process. So I think at this point, we're just gonna pivot over to the Q&A portion. Yeah, so Vitaly, we have a quick question for you. A couple of questions, actually. So first one, I'm just going to read these individually. How optimized do regexes, regular expressions, need to be for YARA rules? And is it important to write regexes efficiently? I'm assuming the answer is yes, but I'll let you go ahead and answer that one.
It's an excellent question. Certainly, there's lots of interesting outcomes can happen because of regular expression matches. Obviously, there are things like detecting domains within the text files are such a complex task, even though there's so many regexes exist. So, and what's important here is that, for example, if you apply YARA across different other tools and engines, there's certain scenario. I remember back in the day when you use your YARA signature across one of the major products, the product could actually really freeze you because so the rule can be very inefficient. So there's a really, you need to be precise and test it significantly when you use regular expressions. And actually, we do not recommend using regular expressions on a day-to-day basis because oftentimes they cause significant slowdown in processing. So it's super important, not only just important to write regexes efficiently, it's super important to double test or triple test it, especially if you rely on sort of like a public repository review of some of the other sandboxes that exist in the world. So it's one of those careful tools that I'm very, or modifiers that I carefully use across my research. I do not recommend, but if that's the only way, you have to test and triple test according to the 7-step process. And the second question is, do YARA rules run only on raw static binary or they run after things have been unpacked? Yes, so there's a lot of process has been done in the world of running signatures after the automated unpacking process has happened. There are tools such as Cuckoo sandboxes that automatically can sort of like a dump raw data, dump raw process memory. So you can actually run YARA signatures across the memory dumps or snapshots done at a certain point of time. So to see in raw memory if we can find those specific signatures. And that's also a critical part, because oftentimes when you think about the malware, you oftentimes hunt for unpacked actually variants. But the golden rule of YARA, if it's possible and attainable, you try to develop a rule that catches both unpacked and packed samples. That's where the art of hunting is come into play. Ironically, or rather surprisingly at first, when I was starting as being an analyst, I realized that APT malware samples, it's at least 20 times easier to find or catch new ones than crimeware family, because oftentimes advanced groups, they basically do not use commercial or crimeware packers, and they reuse the same code. So it's really a small team that develops, for example, nation state capability code rather than the crimeware full funded sort of like commercial underground marketplace that's constantly turning new payload code. So there's a lot of interesting aspects that exist, and YARA signatures can be applied across the memory dumps and the raw files, but still, in my view, YARA signatures oftentimes still are projecting and applying across the snapshot data sets. So it's as soon as the memory dump available, you can run the signatures, and there's certain tools that allow you to do that, especially with volatility, for example, dumps. So it can be applied, but primarily the use case for us is really hunting the malware repositories for new samples and password dumps. It exists, but it's a more complex task, so to speak. Thank you for the question.
Awesome. Yeah. I think we'll just take like another few seconds if anyone else has any last minute questions. Other than that, I'd just like to thank you all for joining once more. And Vitaly, thank you for sharing your wealth of knowledge. I've definitely learned a lot over the past 20 minutes. So thank you so much for all your awesome insight as usual.
Yep, thank you so much, Eddie, for inviting us. Advanced Intelligence, always happy to support, and thank you.
Of course. All right, I think we're all set. So everyone, thank you again for joining, and enjoy the rest of your day. Take care.